Today we are going to discuss non-competitive inhibition in this video. So this is the basic enzyme substrate reaction in which the enzyme combines with the substrate to form the ES complex, which leads to the formation of enzyme, which is the free enzyme, and the product. In case of competitive inhibition, the inhibitor is not the structural analog of substrate, and both of them are unrelated, and the inhibitor doesn't bind to the active site of the enzyme, so there is no competition between these two. The inhibitor rather binds to the other site present in the enzyme, which is also known as the allo site. So if it binds to the enzyme in the allo site, again no product formation occurs. Now we need to know the changes in Km and Vmax as a result of this inhibition. So in my previous video I mentioned about Km, which is the substrate affinity, and Vmax is the maximum velocity. So as we already know that the substrate and the inhibitor are not competitors, so the Km of the reaction remains constant and the Vmax decreases because binding of the inhibitor changes the 3D structure of the enzyme, and the enzyme is no longer in its optimal arrangement to stabilize the transition state of the reaction. Now coming to the equation, this is the normal Michaelis-Menten equation, which states V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. Now reciprocal of this is the Line-Weaver-Burke plot equation, which is this one. The slope of this Line-Weaver equation is this one. So after the inhibition, the inhibitor basically decreases the Vmax by this factor 1 plus I by Ki. So as it decreases the Vmax, so we need to divide the Vmax with this factor. So the slope now becomes this in the LB equation. Now coming to the graph, 1 by V is plotted in the y-axis and 1 by S is plotted in the x-axis. Now we can see from the graph itself that there is no change in Km, but the Vmax decreases and the 1 by Vmax increases in this case. So coming to the equation, the inhibitor can bind both with the free enzyme and with the enzyme substrate complex. This is the unique feature of this kind of inhibition. Now coming to the example, alanine is the inhibitor of pyruvate kinase and iodoacetate is the inhibitor of glyceraldehyde 3-phosphate dehydrogenase. Both these enzymes are involved in glycolysis. Now to summarize this, we can say that the inhibitor is not a structural analog of substrate. The Km remains constant for this, as there is no competition between the inhibitor and the substrate to bind to the active site. The inhibitor binds to the allo site of the enzyme. The Vmax decreases because binding of the inhibitor changes the 3D structure of the enzyme, altering its optimal arrangement to stabilize the transition state. And this kind of inhibition is a reversible inhibition. So the uncompetitive inhibition will be discussed in the next video. You can also view the competitive inhibition in my previous video. If you like the video, please don't forget to like and subscribe. Thank you.